In this segment, we're going to take an example to show you the problems of round-off errors in Navier-Stokes method. So we're going to take an example and see that, hey, we talked about that one of the pitfalls of Navier-Stokes method is that you may get large round-off errors. So let's go and see through an example why that is so. So let's suppose somebody gives you a set of equations like this one, and in this particular example, you need to watch very carefully what I'm trying to do, because we cannot just use our calculator directly to be able to populate through the procedure. And what I mean by saying that is that you have to do each individual calculation and then reduce it to a certain number of significant digits, and I'll point that out in a little bit. -3, 2.249, 7 here, 5, 1, 3 here, 1.751 here, and 9 here. So in this particular case, what I want to do is I want to use 5 significant digits. So keep in mind what I'm trying to use is that in all the operations, so the computer in which you are supposed to simulate this particular problem is you are going to use 5 significant digits. So all the operations of multiplication, addition, division, and subtraction which you are doing are supposed to be done thinking that you have 5 significant digits and you are using the concept of chopping in that. That means that the last significant digit is not rounded off but simply chopped off. So you have 5 significant digits. The 6th significant digit does not make any difference to what the number is because you're using with chopping. Now what I want to be able to do is to be able to show you that, hey, are we getting, do we get the possibility of round-off error? Now what I'm going to do is I'm going to already tell you right in the beginning that the exact value for this particular problem here is 1, 1, 1, and 1. That's the exact value. And in order to illustrate that we are going to have certain round-off error problems here, I'm going to say that, hey, let's go and do this problem with 5 significant digit chopping and see whether we get close to the exact value or not. Now, I'm going to skip certain parts of this particular problem of going through the forward elimination and back substitution, mainly because we have already done that in a separate segment. So this is what we get by using the, so at the end of, so we'll have forward elimination. So in this segment, we are going to talk about the forward elimination. So we'll have 2 steps of forward elimination because we have 3 equations, 3 unknowns. So in the first step, what I need to do is I need to take the first column and make everything to be 0. And this is what I get. So that's part of your homework. You're using 5 significant digits in all the operations. So you get 20, 15, and 10. And at the end of the first step, you're supposed to get 0 here and 0 here. And this is what I get, 0.001, 8.5, 0, 23375. I get 45 here, 8.501 here, and 23374 here. That's what I get at the end of the, no, that's not right. That's not what I get at the end of the first step of formulation. I get 0 here, and then I get minus 2.75, 0.5, and 2.25 minus. That's what I get at the end of the first step of formulation. Keep it again in mind that you do need to recognize that you are using 5 significant digits with chopping in order to be able to generate these numbers. Now I'm going to show you again the second step of forward elimination. I'm going to just show you what I get. So again, this is part of your homework, that you're going to show me that the first step of forward elimination gives you that. The second step of forward elimination will basically mean what? That you're going to use the second row, second column number to be able to make everything below that particular row in that particular column, which is the second column, to be 0. So keep in mind the second step corresponds to second row, second column being used to make everything below the second row in the second column to be 0. So there is some programmatic sense to it. Here again I made a mistake. I should have put x of 1, x of 2, x of 3 equal to whatever I get, which is 45, 8.501, and minus 2.25. And again, this is your homework. Now here what we get is we get 0, 0.001, 8.5, then this turns out to be 0. And here I get 2, 3, 3, 7, 5. X of 1, x of 2, x of 3 is equal to 45, 8.501, and 23374. So this is what we get at the end of the second step of formulation, which we expected that we'll get now a 0 here, and that will give us an upper triangular matrix for the coefficient matrix. And again, as I said, if you look at any of the numbers which are shown anywhere here, they're all shown up to 5 significant digits with chopping. In this here, you have 5 significant digits. Here only showing 2 because it turns out to be that way. Here there's only 1 significant digit because it turns out that way. But all the calculations of intermediate calculation, addition, subtraction, multiplication, and division, they all have to be done within 5 significant digit chopping. This will be much more clearer. What I mean by that is when we do the back substitution part of this particular problem. But let's leave it here that this is what we get at the end of forward elimination. And that's the end of this segment.